Stage 2 of Applications of Calculus. So first thing we're going to do is we're going to go through the relationships between displacement, which is the s function, velocity, which is the v function, and acceleration, which is the a function. What are their relationships in terms of calculus? So when we relate displacement with velocity, the change in distance over time is velocity. So we could say that the first derivative of the s function is equal to the v function. And for acceleration, the first derivative of the v function, the change in velocity over time, is equal to acceleration. And so the second derivative of the s function is equal to the a function. Now let's look at what it means when the s function displacement is equal to 0, greater than 0, and less than 0. So the displacement, when it's equal to 0, means that it is positioned on the origin. Position on origin. When s of t is greater than 0, it means it's on the right side of the origin. And less than 0 means it's on the left side of the origin. For velocity, the velocity equal to 0 means it is stationary or not moving. Velocity positive, greater than 0, means it is moving to the right. And less than 0, the velocity less than 0, means it is moving to the left. Acceleration equal to 0 means that it is a constant velocity. Acceleration is greater than 0 means that it is accelerating to the right. Acceleration is less than 0 means it's accelerating to the left. Okay. Now, when something is moving to the right and accelerating to the right, then it's going to speed up because they're going in the same direction. When something is moving to the left and accelerating to the left, it will also speed up because they're going in the same direction. If the velocity and the acceleration are going in opposite directions, either like that or like that, then the object slows down. Okay? All right. This table is kind of handy for doing kinematics problems, because often in kinematics problems they give you phrases which are codes for knowing the value for t, s, v, or a. And so let's go through some of these phrases. So like the first one is initial conditions. So if they talk about initial conditions, if they say in the beginning, something like that, then the time is 0. That is the beginning of the experiment. It's at the start of the action. Okay. If they talk about at the origin, that what they're saying is that the displacement is 0. If they say stationary, it means that the velocity is 0 because it's not moving, stationary. If it says it reverses direction, then temporarily the velocity is 0 because it goes from being positive velocity to negative velocity by transition through 0, or its negative velocity becomes positive velocity, it also transitions through 0. When something is at maximum or minimum displacement, then that is the moment also that the velocity is 0, because it means that it is the highest value of s possible, and then it's going to start reducing again, or it is at the lowest value of displacement possible, and then it's going to start increasing again. So momentarily it would be velocity equals 0. Constant velocity, of course, acceleration is 0. Maximum or minimum velocity, same reason as above. If something is the maximum velocity possible, then that means the acceleration is momentarily 0 because it's going to transition from being positive to negative or vice versa. Okay? All right. Speed is a scalar, which is the magnitude of the object's velocity. So now finally we're going to do a very big problem here. An object moves in a straight line with the position given by this function, t squared minus 4t plus 3 from the origin, where t is in seconds, t is greater than or equal to 0. Find an expression for the object's velocity and acceleration and draw sign diagrams for each function. Okay, so the displacement function looks like this. We can find velocity and acceleration functions by finding the first and the second derivative. So the first derivative of the s function would be 2t minus 4, right? And then we could find the acceleration function by taking the second derivative of s, which would be 2. Now let's draw sign diagrams for each one. Okay, so for example, velocity equals 2t minus 4. First thing we're going to do when we find a sign diagram is we find out when velocity equals 0. That happens when t equals 2, apparently, right? If we add 4 to both sides and we divide both sides by 2, we're going to get t equals 2 as a critical point. So let's draw a sign diagram. It has one critical point, which is t equals 2. This is the velocity sign diagram. So at 2, the velocity is equal to 0. When we are to the right of 2, if we put in any big positive number, the whole thing is going to be positive, right? If we put in any big negative number, the whole thing is going to be negative. Okay, so that is the sign diagram for velocity. Now let's do a sign diagram for acceleration. So this is pretty annoying the way. Okay, so the acceleration sign diagram is pretty basic because the acceleration function is just 2. So the acceleration is always positive 2. So there are no critical points. Acceleration is never going to be 0. Basically, whatever value of time we put into the acceleration sign diagram, we get positive 2. So basically, acceleration is always positive, period. It's always positive 2, in fact. Okay, so that was the sign diagrams for velocity and acceleration. B, find the initial conditions and explain is what is happening to the object at that instant. Okay, so at t equals 0, let's see what the displacement is, what the velocity is, and the acceleration is. We can use the sign diagrams for velocity and acceleration to find out what happens at t equals 0, because t equals 0 is here, for example, right? Velocity is negative, so velocity is negative. Acceleration is always positive. And what is the displacement at t equals 0? Well, if we put t equals 0 here and here, we find out that the displacement is 3. So the displacement at 0 is equal to 3. So basically, now if we wanted to know more specific values for velocity and acceleration, well, acceleration we know is 2, that's pretty specific. Velocity, we could actually put 0 in here and we'll get velocity equals 0 minus 4, which is negative 4. So we don't have to just be satisfied with using the sign diagram to find if it's positive or negative, but often that's enough. Okay? So what are the initial conditions? The initial conditions are it's at position 3. Okay? It is going to the left at 4, and it is accelerating to the right at 2, which means that since it's going to the left and it's accelerating to the right, it's slowing down, right? So that's what's happening. C, describe the motion of the object at time equals 2. Okay, so again, we could do a really quick analysis by using the sign diagrams. So by the way, displacement at 2 is equal to 2 squared minus 4 times 2 plus 3, which is equal to 4 minus 8 plus 3, which is equal to negative 1. Okay, so the displacement at time equals 2 is negative 1. And the velocity at time equals 2, oh, look at it. It's 0. So the velocity is 0. Velocity is 0 at time equals 2. Velocity at time equals 2 equals 0, which means it's like, reversing direction or something. And then the acceleration, of course, at time equals 2 is positive 2, like it always is, right? Okay. So that's what's happening at time equals 2. It's at position -1. It is reversing direction, and the acceleration is going to the right. Okay. All right. We already did this, right? At what time does the object reverse direction? Oh, we already know that. It's time equals 2. Okay, it's asking the same thing. It reverse direction at time equals 2. Find the position of the object at these instants. At what time does the object reverse direction? Okay, it only reverses direction once at time equals 2. The position of the object at this instant is -1. Okay. Draw a motion diagram for the object. Okay, so the motion diagram, what we do is we draw a S number line, a displacement number line, and we're going to mark on it some of the critical positions, which are basically the starting position and any place it reverses direction. So what is the starting position of the object? Remember, S of 0 is 3. So we're going to put 3 here, and that's actually where he starts. And then at S equals 3, the object is going to the left, right? So it's going to the left. And it's going to go to the left until it reverses direction, which happens at t equals 2, right? At t equals 2, it reverses direction. And then at t equals 2, it's momentarily stationary, and then it's going to reverse direction, okay? So basically, at t equals 0, it's at s equals 3, and then it's going to the left, and it's going to keep going to the left until it gets to the moment t equals 2, and then it's going to reverse direction, and that is at position -1, right? So at -1, it changes direction. So do you see my motion diagram? Basically, I draw out a position number line, and then I kind of like show how the object moves along the motion number line, or along the number line throughout time. So at t equals 0, it's here at 3. At t equals 2, it's turning around. And then it's just going to continue on to the right forever, right? Because like once time gets past 2, then the velocity is always positive, right? And so it's always going to be going to the right for the rest of eternity. Okay, so that's the motion diagram for the object. For what time intervals is the speed of the object decreasing? Okay, so remember, this is constantly accelerating to the right at the rate of 2. So the time interval that it is decreasing would be when the velocity and the acceleration are going in opposite directions, which is during this part, right? Because during this part, it is moving to the left, right? The velocity is negative, but the acceleration is positive, right? So they're working against each other. So during this blue part, it's slowing down. So the time interval that the object speed is decreasing would be t equals 0 to 2. After 2, the acceleration and the velocity are both going to the right, so it's fine. All right, that's it for this last problem.